All right, let's go ahead. First of all, welcome to our webinar. Welcome to the webinar called Stay Ahead of the PFAS Curve. Today, we are joined by friends from Measurlabs, namely Meri Rantanen. Hello, Meri. We also have Jana Trubicina and Lucia Havelkova from Regardis. So welcome, everyone. Just a quick technical check. Please, you can use chat. Make sure that I can already see a few messages. If anyone has any audio issues, feel free to reach out to me directly, either via chat or via email at stano@regardis.com. This seems like all is well. Good morning. All right, so let's get this started. This webinar will be recorded or is being recorded, and the recording will be available a few days down the road after we finish today. The presentations from the speakers, or the slides, as you may call it, will also be available in PDF format. Oh, sharing just disappeared for me. And then a little bit later down the road, we will also compile the Q&As and the most frequently asked questions in the discussions in a white paper format, so you can maybe return to it in the reading format if you prefer. This isn't our first rodeo. Together with Measurlabs, this is actually our second webinar, and I would like to use this opportunity to ask a quick question. I suppose I know the answer mostly, but just to make sure, have you seen the first webinar? Take a second or maybe 5 to answer. Oh, there's plenty of no's. Okay, make sure to check it out. And at the moment, we are at like 40% people haven't seen the first one. So if you'd like, you can go to our YouTube and watch it. After I'm done talking with this introduction, I will link the video, link the recording, and check it in chat, so you can save it for later maybe, or you can watch it simultaneously with this webinar if you're feeling very adventurous. Oh, I haven't shared the results, but it was like 40–60%. I can go back to it. I don't think it's necessary now. Anyway, we come from Regardis. We specialize in chemical management consultancy. I'm sure Jana or Lucia will compliment me on this, but in any case, if you need help with REACH or CLP or only representative services, or with PFAS data collection, which might be relevant to this webinar, feel free to reach out to us. We are definitely looking forward to helping you. And now let's meet the speakers. I've already mentioned the names, but here you can see them on the screen as well. Meri Rantanen, the testing expert at Measurlabs, and Jana Trubicina and Lucia Havelkova, our regulatory specialists at Regardis. And this is the point where I hand the microphone over to Jana. So Jana, welcome, and the floor is yours.
Thank you, Stano. Hello, everyone. So I just now saw how many people haven't seen our first webinar. So I definitely recommend you to watch it. In this webinar, just let me share my screen. Okay, I hope you can see it now. In this webinar, we will be talking about the EPA requirements, which is the competent authority in United States. And during the last time, we were talking a lot about current state of art in EU, where my colleague Lucia Havelkova has presented the PFAS, how are they now regulated in EU, respectively the current state of restrictions development. So during the last webinar, I have just briefly introduced the regulations in US and in Canada. And there are also other countries which are collecting the data on PFAS or evaluating this data and even already banning some PFAS for different uses or intending to ban it. For example, in Australia, they monitor PFAS in environment. So you can see in their website which PFAS were found, in which concentration, and in New Zealand, there is an upcoming ban of PFAS in cosmetics, and so on. So today we will look at the US reporting requirements, data collection, reporting, and how to decide if you need to test your products and where to look for information or advice. And we will be happy if you indicate your interest in other regions, like, for example, Canada, which I was going to prepare for this webinar, but I realized that the US topic is too big to cover it all during this session. So we can maybe prepare some other webinar with requirements of Canada or New Zealand or Australia, China, or, for example, Japan. So maybe now it's a time for Paul, where you could tell us what regions you would be interested in. There is also option other, so you can elaborate below. You can tell us what you're interested in, and we did not include here the EU, but of course, if the European Union PFAS regulations is your biggest interest, feel free to put it there also. Okay, so it will take how much time? 40 seconds, minute, less.
Well, let's let it keep going. I don't think we need to share the results at the moment.
Yeah, sure, that's perfect. Okay, so I already indicated what we are going to talk about, and also there is a very important question, which is where to look in for PFAS. Where are PFAS in my products? If I'm buying some articles, for example, where it is. So the answer is basically everywhere. You can see here on the screen just some uses where the PFAS can be found. Can be packaging, food contact materials, textiles, electronic, firefighting foams, and so on and so on. So it's so many uses. It's not even all in this slide. So today also we are going to talk about the deadlines, extensions of deadlines, reporting options. We will look briefly at the reporting manual, and it will follow with some practical advices. We will be happy to see all your questions in the Q&A. So let's start with the most important. What should be reported under the EPA TSCA section 8A7, which is reporting and record keeping for perfluoroalkyl and polyfluoroalkyl substances. That's a hard one. All right, so you must report the PFAS which were imported or manufactured in the period from 2011 to 2022, which is quite a big time to look back. And what needs to be reported is PFAS uses and production volumes, disposal, exposure, and hazards. However, which PFAS are reportable is it of all of them, or there is some list of it. So according to the EPA, there is no special list of chemicals. It's more about structural definition, and also the substance should meet the definition of a chemical substance under the TSCA. Also, EPA has prepared a list of chemicals, which is not the full list because some substances or some information is confidential. And also here is the link for the webinar on final PFAS reporting rule under the TSCA that was launched by EPA, by the competent authority. So I also recommend you to watch it. It also has Q&As, so there are some questions answered. Here are also the links to additional resources page of EPA, and there is a list of PFAS chemicals that was uploaded. This is a direct download link, however, the list is not full. So just once again, the reportable PFAS are the PFAS that are meeting the structural definition, which you can read maybe after the webinar in order not to take your time now. Also, as I said, the substance need to meet the definition of chemical substance under TSCA, which is quite similar to definition under the REACH. Also, there are other databases and resources recommended by EPA, and some substances in these databases might not meet the structural definition of the substance under the TSCA. So the deadlines for PFAS reporting in US have been moved. So now it's January 11th, 2025, when the database will be opened in July 2025, and there will be 6 months of reporting for almost everyone, and then there will be 6 additional months for the small businesses which are reporting only PFAS contained in articles. So the reporting guidance contains all the information who should report and how, when, the reporting instructions for each part of the reporting form, the decision diagrams, what should I do if, and also there are 2 reporting forms which are standard and streamlined, and this guidance also contains registration guide to CDX system. Also, EPA is recommending to register to CDX system right now if you already know that you have reportable PFAS, because it will help you to make sure that at the time of reporting everything is working, you have the access. So what is the streamlined reporting? This is the reporting which is a bit simplified. It is a reporting for those who report only articles that contain PFAS. So it means you do not import or manufacture substances itself. And there are reduced information requirements, and you can also be able not calculate the total volume of the substance, but just the number of articles or quantity or weight of articles. And also you can submit additional information such as, for example, SDS. For R&D or research and development, you can also use this streamlined reporting form. If you have less than 10 kilograms per year, if you have imported or manufactured this substance, PFAS substance, only for research and development purposes. And now let's briefly talk about the data collection challenges. There are many, but the most concerning are, first, it is the reporting period. It's more than 10 years that you should look back and search for information. So it can happen that some companies stopped their work, they were sold to other companies, they renamed, they might not have some data, and also some suppliers might not respond because they do not have enough knowledge on PFAS problematics, or they're not affected by the regulation, and they're not interested to collaborate. And also there is maybe a very long supply chain, so it is very hard to find the information. So how to collect the data? The EPA requires all submitters to perform a due diligence and report that information that is reasonably ascertainable. So this is not only the words that we can just interpret as we like. There is a strict definition. It is information that is in the person's possession or control, and information that the person should have, like, for example, files maintained by manufacturers, SDS, or some customer surveys, sales report, and so on. And guidance also contains several examples where you can see some model situation and then see how to fulfill your duties. So how to collect the data? I wanted to prepare some kind of decision diagram, but basically it's not really it. So you can be a substance manufacturer or importer, or you can be mixture importer or manufacturer or article importer. So this seems to be very clear. If you manufacture something, you know the composition. If you import, you can obtain information from your manufacturer. But here where the problem comes up because if you import the mixture or article, your supplier, first of all, they can not know the information, or this information is confidential. They do not want to open the composition, so it might be really hard. So we have just some practical examples, some advices what to do. First of all is to set the right communication, educate your suppliers, remind them about the obligation, motivate them by because they might need this data also, and always collect the evidences of the communication. Since we are talking about reasonably ascertainable information, you can also check the supporting documentation such as SDS, and also approximate information in quantities. For example, in this year we have imported that substance in that quantity, so probably we can just approximate it to other years. And one of the options also is to contact the laboratory for testing, to pick a representative sample and test it, and further approximate it to the product line. Since I'm not the analyst, I would like to give the floor to Mary from Measurlabs, who will be talking about testing now. I hope I didn't took too much time. I hope I put it all in almost 15 minutes. So thank you very much for your attention. And on the next slide, once you receive the presentation, you will find some useful links, resources, and also the contact for EPA. This is specific email for this rule, reporting rule on PFAS. And I can recommend you to contact the authority if you have any questions. And also here is the frequently asked questions which were already collected. Thank you for your attention. And Mary, I'm giving the floor to you.
Thank you, Jana. Just a sec, I share my screen. Can you see it now?
We can see it now. Perfect.
Yes, great. Let's start the section of this webinar where we discuss about the case examples and which kind of test plans can be done for different sample types when you are planning the analysis. In this presentation, we have 4 case examples: PFAS analysis of environmental samples, packaging materials, textile products, and process chemicals. And for those who didn't attend the first webinar, I want to introduce myself and our company. I'm Measurlabs, and I work as a testing expert here at Measurlabs. I have been working here now 1.5 years, and I'm a chemist from my background. And in my work, I concentrate mainly on PFAS projects. Then I handle also a lot of projects related to elements and ions and environmental samples in general. And in addition to those, I work closely also with different chemicals, waste materials, and samples from different industries. And for those who are not familiar with Measurlabs yet, we are a new kind of laboratory testing service provider, and we have combined services from over now 900 laboratories as one service, and we arrange and sell testing services in cooperation with our partner labs. We have 6 different teams and help with all kinds of samples and materials and arrange almost any test you want to order. And for example, for PFAS compounds, we have several laboratories in our network who have specialized into different sample types, and for that reason, we can provide tests for many different sample types. Before we hop into the actual topic, I want to mention a couple of general notes. The field of PFAS analysis is still in its early days, and the analyses are constantly developing. And test plans are quite often really customized, and there is no just one correct way to analyze different sample types. And these case examples in this presentation are not actual projects that we have had with our clients. Instead, these examples are just examples, and there might be also other ways to approach the testing. After this presentation, I hope you have gained some inspiration, and I hope this presentation gives you some ideas on how to start planning analysis for your samples. But let's start with our first example, environmental samples. Environmental samples can include a lot of various sample types, but we have selected water and soil to this presentation. Usually with water and soil samples, the test plan includes the targeted PFAS analysis, and depending on the aim of the study, the analysis packages usually contains 20 to 50 compounds. Typical detection limits for the targeted PFAS are usually on PPT or PPB level. And for soil and water samples, I think the most used analytical method is EPA 1633, but I also wanted to mention one alternative analytical standard method from DIN in this presentation. Fluorine analysis, total fluorine and total organic fluorine, are less frequently done, but there are a lot of suitable methods available in case you want to concentrate, for example, fluorine analysis before you move to targeted PFAS. And what is good to keep in mind with water and soil samples is that there are quite a lot of methods available already, but the packages, detection limits, and prices can vary a lot. So it might be a bit difficult to compare the analysis packages between different service providers. And if the samples are contaminated or polluted, they may be difficult to analyze. For example, if you have really contaminated a wastewater sample, it might be quite difficult to analyze. And for especially challenging samples, it might be difficult to achieve as low detection limits. And the detection limits might increase during the analysis. Then our example number 2, packaging materials. And one good example could be, for example, cardboard and paper packages. And the reason why the PFAS analysis are done is quite often that the clients want to study the regulatory compliance. And typical test plan usually includes fluorine analysis and targeted PFAS analysis. Nowadays, it's quite common that our clients ask the analysis packages where different forms of fluorine are analyzed separately. In those cases, usually the package includes total fluorine, total organic fluorine, and inorganic fluorine. Typical detection limits for fluorine analysis varies from 1 to 10 ppm, but there are also applications available where lower detection limits are achieved. Usually when analyzing targeted PFAS from cardboard or paper packages, the analysis package usually includes 30 to 50 compounds. And from these samples, especially PFOS, PFOA, PFHXS, and related compounds are included. Typical detection limit for targeted PFAS usually is on ppb level. And I have listed 3 common standards in this presentation that can be used for the analysis. There's 1 standard from SEN and 2 standards from EN. And what should you keep in mind when planning analysis for packaging materials is that, especially if the analyses are related to the regulatory, the selection of the method has to be done super carefully. And especially now when regulations are still new and constantly evolving, it's quite important to check that the method you select fulfills all the requirements. Then our example number 3 is textiles. And we have selected as an example outdoor jacket. The typical reason why these kind of samples is wanted to be tested is that the client want to prove that the product is PFAS free. And usually with textile products, it's quite typical to start with fluorine analysis. The suitable applications are total fluorine, total organic fluorine, or extractable organic fluorine. And detection limits are usually from 1 to 10 ppm. After fluorine analysis, it's quite common to continue with targeted PFAS analysis, and usually 20 to 50 compounds are included to the packages. Typical detection limits are on ppb level. And one specialty with textile products is that quite often it is seen that laboratories offers also analysis packages where certain groups of compounds are analyzed as sum. And one good example could be, for example, a sum of C9 to C14 PFCA. Also, the same analytical standards or method standards are used with textile products as packaging materials. There is one standard from SEN and 2 standards from EN. And really important thing what to keep in mind with textile products is that usually, for example, if you think outdoor jacket, it might include several different materials, for example, fabrics, plastic, leather, or even metallic parts in some cases. And if you want to get reliable results, each of these materials should be tested separately. And combining all the different materials is not recommended, because if we combine all the materials to the same analysis, we can't detect where the fluorine is present, and then also the heterogeneity of the sample is so high that the measurement uncertainty increases to the level that it shouldn't be. Then our last example, process chemicals, and already at this point I want to mention that this is probably the most difficult sample matrix. And the typical reason why chemicals are tested is that some external party is asking if the product includes the PFAS compounds. And before we go to technical details, I want to note that practically always analyses from chemicals are customized, because there are so many different chemicals in this world, and it's not possible to use the same method for all different chemicals. Usually, the typical test plan for chemicals includes targeted PFAS analysis, and depending on the client's need, it can be analyzed just one specific PFAS compound, or then we can investigate as extensive packages as possible. Typical methods used for chemicals are in-house methods, or in-house methods that are based on some official analytical standard. And for some sample matrices, fluorine analysis can be performed, but the analytics are much more complex than for simple matrices. For example, if you compare chemicals versus paper matrices. And then what to keep in mind is that chemical matrices are usually quite complex and challenging, which means that the detection limits it's quite difficult to estimate the detection limits, or the detection limits might be relatively high compared to simple sample matrices. And the suitability of the analytical method should be verified case by case, and all laboratories do not accept strong chemicals. For example, we have a couple of laboratories in our network who have specialized or have good experience with chemicals, so most likely also the difficult chemicals can be analyzed. And one really important topic with chemicals is that they might include dangerous goods, or the chemical might be dangerous for your health, or harmful for the analytical instrument. So working safety aspects need to be taken into account when analyzing chemicals. Then our last slide is or we wanted to give you some tips when you are planning the analysis and you are contacting different service providers and ask offers for PFAS analysis. There are some topics that should be mentioned when you are conducting laboratories, and they can be found from the bullet points. First of all, tell to the lab what is the sample material you want to analyze, and try to be very specific. In that way, the laboratory can easily check if suitable methods are available. Then please tell the laboratory if the analyses are related to any specific legislation, because if you don't tell that, the laboratory can't know that the analyses are coming for regulatory purposes, and they can't check if the method is suitable for that purpose. And then if you know, you can also list already some specific PFAS compounds you want to analyze, or if you know the concentration levels or detection limits you want to achieve, you can mention also those. But don't worry if you don't have all this information available at the beginning of the process, because most of the laboratories can propose suitable analysis packages too. And yes, thank you for your attention. At this point, I want to mention that even though we had only 4 different examples in this presentation, we provide analysis for many sample types. So if you want to discuss later or need help with your analysis, you can always contact us. Thank you.
So thank you, Mary and Jana, for insightful presentations. And this is a place to move to the discussion part, and for which I didn't mention at start some rules. In general, we would like to prioritize people who want to talk live, just to make the webinars a little more interactive. But and I've already seen a few hands pop up during the webinar. I'm not sure if this was people just trying the button or actually wanting to talk. But before you raise your hands, just to note that live questions will be prioritized. Then we'll go through those posted in the Q&A sections. I noticed multiple people posting questions in chat, so I included some in the Q&As and all of them in my presentations. Presentation I will be sharing. And before I do so, I wanted to ask if there is anyone who would like to ask live at the moment. Just raise your hand. I will allow you to turn on your microphone. Oh, there's Javit. I think you also asked in the Q&A. So let me quickly find the question, just so I put it on screen. Oh, okay. I've missed it. Oh, no, I didn't miss it. It is there. So there you go. And, okay, Javit, Javit, I'm sorry if I'm butchering your name. I'm allowing you to talk. You can unmute yourself now.
Yes, hello everyone.
Hello.
You can hear me?
Yes, we can.
Thank you very much for the webinar and for presentation. The question is, as mentioned in the screen, so I have written it, just like I wanted to speak live to precise in more details, if it's not clear enough. I have been working with Measurlabs. It's been almost 2 years. So we did a lot of samplings, etc. And it was one of the frequent cases that came to the table. So when we had some samples from our products that we are in the process of producing it, most of the times the problem was that there was some impurities inside the sample. So we are the producer of the plastic components, the fittings, pipes, etc. So which is like naturally we have some protective agents and processing aids, antioxidant, anti-UV. So you can easily find more than 10 ingredients in one mixture of sample. And in most cases, we need to analyze this kind of sample. And in the PFAS scenario, my question is the following. In PFAS scenario, is it the same? Like when you have a couple of ingredients which we don't have any other option to avoid them using. Is it causing some kind of challenge for you to measure and to give us the good feedback?
I think this question is quite technical already, and I don't have the answer to you yet. But if you can, you can send this question to me by email, and I will check the details and try to answer you as best I can.
Okay, we can do this way.
Yes.
How can I find your email address? It's
you can find it from our website, and it's also mentioned in the presentation after.
Okay. Great, thank you.
I will also link it in chat in a second. Before I do so, thank you, Javid, for your question. Anyone else who would like to raise their hands at the moment and talk live? Oh, there's Jan Carlos. Jan, I don't think you put the question in the Q&A, so I'll leave this one on screen for the moment, but I can allow you to talk now. You can unmute yourself.
Hi, can you hear me?
Yes, we can.
Yeah. I have also a question for Mary. If the matrix of the probe is so difficult, how is it possible to measure PFAS in articles made, let's say, of polycarbonate?
Well, that's also quite a technical question already. There are different methods available for different matrices, and the suitability of the method should be checked case by case. I don't have the direct answer to this specific sample matrix already for you. I'm sorry for that, but we can definitely check if suitable methods are available for the sample types that you are asking for.
Yeah, then I have a follow-up question. Would it be possible to do a pyrolysis GCMS for it? Or wouldn't that be suitable?
I haven't had a project where pyrolysis GCMS have used with PFAS compounds, but one of my colleagues is really familiar with that technique, so we could check if that could be one possible method.
Okay, thank you.
Thank you, Jan, for your question. You can lower your hand. And then we have a question from Veronica. I sincerely hope you're the same Veronica, as I put only the first name here. But I will allow you to talk, Veronica. Oh, Mary is getting them all today.
Yes. Can you hear me?
Yes, we can hear you.
Okay, that's great. I have a question for Mary. We've done some PFAS analysis with Measure, and now that PPWR is giving new threshold value for PFAS, my question is, would it be possible to say that the material that we've tested is compliant with the PPWR PFAS requirements?
Yes, we can definitely check the concentration levels and check if the concentration levels are meet the requirements. But one of my colleagues is specialized with PPWR, and for example, if the question is related to the packaging materials, I would like to consult him before give you a straight answer.
Okay, thank you. I can send you an email after this, and yes, it is certainly about the packaging materials.
Yes. Great.
Yeah. Okay, thank you.
Thank you very much for all the questions. I'm seeing plenty technical questions in here. But there are no other raised hands, so let's move to the Q&A queue. And we picked a few from the registrations. We picked a few from the Q&As asked live. I would like to start with this one, which caught our eye. It's from Basil. And to give Mary a little break, let's go for a regulatory question. Jana, so Basil is asking, what if our supplier hasn't responded to our PFAS request under TSCA Section 6? Is mandatory testing required in this case?
Yeah, thank you for this question. I've noticed that there is a different section mentioned here, which concerns PBT or persistent bioaccumulative and toxic substances. So in case this is it, it's basically not about PFAS. However, when you're in general collecting the information, the data, and your supplier does not respond to you, you can also you can always contact the authority, the EPA. If it's about PFAS, which is TSCA section 7A, then in this case, as I was saying in the presentation, you need to collect the data that is reasonably ascertainable. So if you do not get the answer from your supplier, you can consult, for example, SDS or some other documents that you have received with the order. And also, yes, it is possible to test the sample, but it is not mandatory so far under the US EPA. And if we're talking about TSCA section 6H, which is about the PBT substances, then this rule requires the workplace safety protection for the workers, the reduction of exposure. So there, I think that it's better to test. If you are not sure what substance is there or in which concentration. So in this case, you can have all the information needed, and you can assure that your workers are protected and the release and exposure is under control. If you would like more information about this, please elaborate in Q&A or contact us by email.
Okay, thank you, Jana. Let's get back to Mary. And I would also like to get back to a question which was asked on a previous webinar, and we have probably missed it by Arta. And this question reads, why are NMR techniques not utilized to detect the presence of a fluorine nuclei? And I also included a question by Payal, who is asking which other analytical methods besides NMR can be used to detect PFAS, which I felt was related to Arta's one. So I think this is again headed for Mary.
Yes, I know that there are several methods available for PFAS, and one of them is NMR, if I remember correct. But I didn't include those to my presentation because I wanted to show the analytical methods that are commercial available easily. For example, NMR is quite expensive technique and all labs don't have it. But especially if you know that you want to test your samples with some certain analytical technique, please tell it to the labs or service providers, because then we can check if suitable analytical method is available for the samples. And other than NMR methods, the most typical methods are for fluoroanalysis, combustion ion chromatography, and for targeted PFAS, the most common techniques are liquid chromatography combined with mass spectroscopy, and then some applications are also done with gas chromatography combined with mass spectroscopy.
Thank you, Mary. Thank you. Let's hope this answered the question for both Arta and Payal. Payal also asked a second question, which read, what are the challenges in detecting and measuring PFAS? And I would let Mary answer this if you'd prefer, but I think it would be very good to to direct you to the first webinar where Mary went into great detail on exactly this question. What are the challenges in detecting and measuring PFAS? If there's anything you would like to expand upon now, Mary, you can use this opportunity. I think your first webinar was very thorough on this.
Yes, I also recommend to watch the first webinar. There are quite many challenges that are mentioned in there.
There is a question by Stan who asked, how can you control... I lost it here. There it is. How can you control the potential contamination of samples with PFAS during analysis? In several analytical equipment, like tubing, vials, syringes, they might contain PFAS. So how to ensure they don't bias the measurement?
Yes, the contamination is truly a risk with PFAS because they are used almost everywhere. The laboratories who analyze PFAS compounds are really good at that, and they ensure that instruments and parts of the instrument don't contain PFAS. But the most important thing is to check that all the sampling equipments and the containers are PFAS free. If you take the samples to the containers that are made from, for example, plastic that include PFAS, then it's almost sure that the samples are contaminated. So the contamination should be taken into account when samples are taken, and then the laboratories who analyze PFAS take care that the instruments and their equipments don't include PFAS.
Thank you, Mary. If any questions receive answers you would like to follow up on, do not hesitate to reach out either via chat or via email to Mary, Jana, Lucy, or me. We'll get back to you for sure. I would like to use these final 10 minutes for maybe 1 or 2 questions for the end. And going back all the way to the start of the queue, there's a question by Yasser, who is asking, how about PFAS analytical methods in food? So again, Mary, you are getting the long end of the stick today.
That's totally okay. Yes, there are a lot of analytical methods available for food samples, and we have worked with those matrices as well. Typical samples could be, for example, fish or egg samples, and typical detection limits for PFAS could be something like PPT or PPB level. But with food samples, it's a bit difficult aspect that if you must send the labs to the different countries, there might be some issues with customs. But otherwise, the PFAS analytics are quite simple for food matrices.
Okay, thank you, Mary. With this, I have one final question which I would like to use to close this webinar. But before we get to that, I want to ask if there's anyone who would still like to comment on anything live. It's very easy to miss people when there is this many of them. I just want to make sure that we aren't excluding anyone. Okay, so I would like to use these final minutes of the webinar to quickly comment on this question, which popped up during the first webinar a lot, during the registrations, as well as during the live discussion, and also popped up during the second webinar registrations. And this question/comment or inquiry pertains to the industrial dependence on PFAS products, be it in technical textiles or other fields. Lucy, do you want to comment on this?
Yes, sure. Well, I would say that the industry dependence, or at least that, well, industry dependence is definitely significant I would say that PFAS are used greatly in many major industry sectors, and they can play a crucial role for many sectors. And the evidence for this dependence could be the huge number of comments which were received during the consultation period. Nevertheless, to elaborate further on that, or to dive more into the industry strategies and to the foreseeability of replacements and other technicalities, I would say it's like quite beyond the scope of this exact webinar. But maybe if some of you would be some of you who are from the industry and maybe would be willing to share more if you have some specific experience with this replacement strategies and would be willing to share, it might be an interesting topic, maybe for some other webinars or other like discussions. So, well, feel free to reach out if you would be interested in something like that.
Okay, thank you, Lucy. I would like to quickly reiterate, we feel this topic deserves more exploration or more discussion, but it's probably too specialized in each field to talk about it broadly on this exact webinar. But we didn't want to. I'm missing the word in English now, but we didn't want to leave out this topic as it popped up a lot. We don't want people to feel unheard. So this is the end of our second webinar together with Measurlabs. Make sure to check them out. Thank you to Mary, thank you to Jana, and thank you to Lucia for your participation. Thank you to everyone who asked questions, be it live or during Q&As. If your questions weren't answered, we will try our best to get back to them in the Q&As, in the Q&A sheets we will be sending out down the line. It will take us more than a few days to properly answer everything, but we'll do our best to do so. Please take a minute or two to fill out our feedback survey. I posted the link in the chat. I will post it again. I know that this is something which is the favorite activity of everyone, but I just wanted to make sure that you know that it is very important for us to hear your feedback. We try our best to accommodate or adjust these events to make them good for anyone. So thanks again to anyone for participating. I hope these webinars are useful for you. They were definitely very fun to coordinate from our point. Thanks again to Measurlabs for joining us in the discussions. And thanks again for Mary, Jana, and Lucia for their contributions with the presentations.
And thank you, Stano, for being such an amazing moderator and technical support also.
Hey.
And thanks to all participants for being here today with us. Thank you.
Thank you. Goodbye.